All right, let's go, let's go, let's go. Oh my God, I feel so much better than I did this morning, but my voice still is awful. Unit 9, date. Day 2. Gotta go day 2. Homework and notes. What I don't finish is yours. Oh my God, you're so welcome. Let's just start right with the cool blue pen. There it is. Oh my gosh, what were all those choices? Wow. I'm just staying with cool blue though. All right, kiddies. This was a warm-up. Shouldn't be a no-brainer. Sine of A is 9/41. We might need a calculator for this one. Well, I might as well get that baby running. Oh my goodness, I got too much open. Go away. That should be going. Oh my God, let me get here. One note. All right, so we're in the second quadrant. By the way, just in case you're wondering, this will be negative, and so will this. Now I don't have to worry about the signs anymore. I know the denominator of this one's 41. 9/41. Remember, because sine is opposite over hypotenuse. That's what all the cool kids say. So I do 9 squared plus x squared equals 41 squared. So on my calculator, I'll just do, and this is, some of you ought to start doing this, get a little smarter, use your brain. 41 squared minus 9 squared. Where'd I get that from? My brain, kids, my brain. Well, my brain's saying shut up because you're looking like a fool. 91 squared minus 9 squared. I don't know, I just type in 81. It'd be much easier. 1600. So x squared is equal to 1600. The square root of 16 is 4. The square root of 100 is 0. So this is 40. So my missing side is 40. So the cosine, since we're in the second quadrant, that's why I put the negative over there, is negative 40. And then this would just be negative 9/40 because it's opposite over adjacent. Moving down, kiddies. We're in, let's see, this is 180 degrees and this is 270 degrees. That makes this the third quadrant. So I'll come down here, I'll draw a triangle in the third quadrant. And I know that cosine, which is adjacent over hypotenuse, is 4/5, so that makes this 3 automatically. Sine is negative in this quadrant, but tangent is positive, so we'll leave that positive. And here we go. Cosine is negative 3/5. Tangent is positive 3/4, and we're finished. All right. It's at this point which you probably ought to, very, very quickly, pause this. I don't know what I'm saying. Pause this, and then for about 1 minute, go for 1 minute and see how many of these you can get in 1 minute. Because the faster you get at this stuff, the easier math becomes. How many of you can finish this in 1 minute? We're going to do it again in class. All right, so at this time, you're going to hit pause. Pause now. Hey, welcome back. Here we go. Ready? 1/2. Square root of 2/2. 210 reference angles, 30 degrees. 30 degrees of sine is negative 1/2 because it's in the second quadrant. Cosine of 30 is the square root of 3/2. Cosine of 45 is the square root of 2/2. 270 is straight down, that's negative 1. Sine of 60 is the square root of 3/2. 135, reference angle is 45, second quadrant. Sine is positive in the second quadrant. Cosine 30, reference angle is 30, fourth quadrant. Square root of 3/2, positive. Cosine of 60 is 1/2. Sine of 240 is 60 degrees away from 180. Cosine of 60 is 1/2. We're in the third quadrant, negative. And finally, 315, 45 degree reference angle. It's in the fourth quadrant. Cosine's positive in the fourth quadrant. There we go. Those are some things you should be thinking about. Bum, 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 bum. All right. So when I say exact value, you say, put your calculator away, you dummy, right? Exactly. So if I have to do this without using my calculator, but I don't know anything about 15, just like with sine, you have to use your formula sheet, and we have to come up with some way of making up 15. So before I even go to my formula sheet, because I'm going to use my sum or difference formula, my favorite angles are 30, that would be 30, 45, 60, 0, and 90. Well, 0 is kind of boring. We're not going to really use that much. But these 4 we probably will use a lot of. And I think it should be obvious that either 30 and 45 or 60 and 45 I can use to make cosine of 15. So I'm going to do simply 45 minus 30. Because clearly this is 15 degrees. Right? Because it's 45 degrees minus 30 degrees. All right, so come over here my formula sheet. And I'm looking for subtraction with cosine. Well, that's right here, chillin'. Blow that puppy up for you. So there's my subtraction with addition. It's cosine plus. Now notice this is something that gets kids missing. Even though this is plus, this is minus. So you got to follow the right formula. So it's cosine, sine, but the sign changes. It's now positive. So, whoa, what the heck? So we'll go down here to day 2. And so what we're going to write is, and this is A, and this is B. So I'm going to write the formula as it's written. It says cosine A, cosine B, plus sine A, sine B. Well, A is really 45. And B is really 30. Now I'll use my parentheses. Plus. Oh, you gotta go. Cosine 45, square root of 2 over 2. Simple. Cosine of 30, square root of 3 over 2. Sine of 45, square root of 2 over 2. And the sine of 30 is 1/2. This should all look familiar, chillin'. You multiply these two, you get the square root of 6 over 4-bagger, plus the square root of 2 over 4-bagger. And this is the square root of 6 plus the square root of 2 all over a 4-bagger. Cha-cha! Oh my God, math is so much fun. So they want us now, they're telling us to use this formula. Now if I look at this, it should come as no surprise to you that the cosine of the sum formula is cosine, sine, but notice, minus this time, right? Minus. Be careful. Be careful. Don't make silly mistakes. So I'm going to write the formula down. Cosine A plus B is equal to cosine, sine. And this should come as no surprise to you. This is similar stuff that we've already done before. You know, I give you part of it. You got to find the rest, okay? I can't give you everything. If I gave you everything, it'd be enough for you to get because you got it all because I gave it to you. So I give you cosine of A is 15 over 17. So I come over here and I go 15 over 17. And I give you sine of B is negative 4 over 5. All right, but I don't give you the other two. So let's deal with this. Angle A is in quadrant 1. It's from 0 degrees to 90 degrees. So I know it's positive. And I was told that the cosine, which is adjacent, over hypotenuse 15 over 17. And then for my just sheer brilliance, I know that this is 8. And again, you just do 17 squared minus 15 squared. Or you can do 15 squared plus x squared equals 17 squared. Subtract 15 squared. There it is. But it's 8. So the sine, the sine of A, which has to go here, is 8 over 17. Now we need to work with B. B's a little trickier. Angle B is from 180 to 270. So that puts this in the third quadrant. And it tells us that it's 4 over 5. Opposite over hypotenuse. And of course this side is a 3. So if I want the cosine of B, I should have put a B there. It's negative 3/5. Now I can put this in my calculator, but this is negative 45 over 85. Plus, why is it plus? Because we have a negative here and a negative here. 32 over 85. Well, negative 45 plus 32 is in fact negative 13 over 85. Yay! Oh my God! Uh-oh. Got a difficult problem coming. Alert! Alert! Crazy problem! Crazy problem! Whew. I just love math. If there's anything better than math, I don't even know about it, except for maybe pizza and ice cream. Oh yeah, a night of pizza with ice cream. What do I care? Can't even taste it. Coffee. Okay, so we have an issue here, and here's the issue. This thing right here. First of all, I told you a while ago, if you see a 2a, that means you have to go to your formula sheet. And this was the information I was given. So we got a little bit of work to do. So let's go look at our formula sheet. Come back over here to the formula sheet. Now, I told you before with sine it was a little bit easier, but with cosine and a double angle, it's a little trickier. We've got 3 formulas. Notice this one uses sine and cosine. Just cosine and just sine. Now you get to choose. It doesn't matter which one you use. All 3 of these are the same or equally as equal, will give you the same result. You just have to do the work. Well, in this particular problem, we were given sine. So if we come over here to our formula sheet, would it make any sense to use something that had sine and cosine? I don't even know what cosine is. Would it make sense to use just cosine since I don't know what cosine is? Or would it make sense to use ding, 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 the sine formula, which is 1 minus 2 sine squared a. Now, I'm going to write this a little differently because I want to make sure you understand it. So in this case, we're going to use cosine 2a is equal to 1 minus sine of a squared. This is the same as this. It's just that this way of reading it is a little bit easier than this way, okay? So when I'm going to write sine of a squared, or I'll read this in class, sine squared a, but it's really the sine of a squared. Now, why do I really harp on that? Well, then I'm pretty much done with this problem. I was told what the sine of a is. It's right here. So I'm just going to plug that thing in right there into this formula. 1 minus negative 24 over 25 squared. And that I can just type right into my calculator. 1 minus parentheses, control division, negative 24. Now, I don't have to put the negative in there. I don't have to put the negative in there because I'm going to square it anyway. It'll be positive. So, enter. 49 over 625. Ka-chang. So, what are we looking here? Half angle formula. There it is, cosine half angle. So what we're going to do is go back to our formula sheet. And we're going to see if we can find those half angle formulas. We need to find the cosine. The good news is there's only one. And once again, the good news is it just uses cosine. So it's 1 plus cosine a over 2. Don't have to memorize this. Oh, wait a second. Let's back up the crazy train. Let's back up the crazy train. Just thought of something. Where's my... Gotta go back to here. Let's go back to this problem right here. We have to think about the sign here, kids. It's pretty tricky. We got to think about the sign here. Should be all right, but we should have to think about this. Our current angle is in quadrant 3. Let's think about what that means. Sorry. Quit smoking. Somehow, somewhere our angle ends up down in here. You know, I don't know where it is, but it's down in here somewhere. So that means its lowest it can be is like 180, and the highest it can be is 270. Now, I know it can't be 180 and it can't be 270, but it can be really close. But now I'm doubling it. So if you double 180 times 2, I get 360. Oh, that's right here. And if you double 270, I get 540. It's weird. So 540 minus 360. 14. I have no idea. I don't know why, but my brain's not working right now. 540 minus 360 equals 180. So that means my angle should... So I actually should have told you I want the positive or negative. Well, in this case, it's just positive. I don't know if I'll be that tricky. This next one's a little bit more tricky. So actually, my new angle could be between 0 and 180, which means I'd have to tell you whether or not I want a positive or negative, because if, in fact, it ended up way over here, I would have to give you a negative value for this. Even though it came out positive, I'd have to give you a negative value for that. Tricky question. Not going to go there that much on the test. Same thing here with this. This one I'm telling you I want the positive. So the formula for the cosine of 1/2 x is equal to equals plus or minus 1 plus cosine x over 2, which is equal to, and since we only want the positive, let's just get rid of the plus or minus and just work with this. 1 plus negative 7 over 18 all over 2. Let's see, that's 18 over 18 minus 7 over 18 is 11 over 18, which makes this 11 over 16. So this is really just the square root of 11 over 16. Now, if you can't do this math in your head, I'm okay with that. Use your calculator. But it just turns out to be the 11 over 16, which, of course, is just the square root of 11 over 4. There's our answer, kids. Positive. We only want the positive. I gotta look at my notes. What am I doing next? Oh, shoot. I can bring my notes down here with me. I'm gonna have to pause. I don't want to do all these problems. Hold on, I gotta go. I'll be back. I'm back. Let me make sure I'm still recording. Yes, I'm good. Let's get rid of you then. All right, next problem is problem 5. Bye. Problem 5. All right, let's try not to be a jerk. All right, so just another example of one of these. I figured I better give you a couple of them. I wanted to try to do half of them anyway and then give you the other half. Ooh, forgot a pie here. So we don't know anything about 165. And I told you before, if you remember correctly, if it ends in a 5, more than likely you're going to use 45 plus some other relatively nice angle. Now in this case, what I want to figure out is what number I have to add to 45 to get 165. And clearly that's 120. Now is that a nice angle? I hope by now you know that is, right? It's 60 degrees. But we're not going to use 60. You have to use 120. Now, if you go over to the cosine formula, it's cosine A, cosine, oops, that should be 45. I don't know why I just did that. Cosine B minus sine A, sine B. Now, you have to be very, very, very careful of the signs. Cosine of 120, since it's in the second quadrant, is negative. This will be positive, this will be positive, and this will be positive. But this is the one right here that would cause you problems and probably mean you're going to get it wrong. So just be careful of those signs. Always be careful of the signs, okay? They're the ones that are going to come bite you in the booty. All right, while I'm drinking coffee, I'll get these filled in. No, okay, hold on. This is the square root of 2 over 2. This has a reference angle of 60 degrees. Cosine of 60 is 1/2, but since we're in the second quadrant, it's negative 1/2. Square root of 2 over 2. This is the reference angle of 60, and the sine of 60 is the square root of 3 over 2. So this one I get negative radical 2 over 4 minus radical 6 over 4, which of course is just negative 2 minus radical 6. That's a 6. It's a great looking 6. All over 4. I'm just trying to stay away from this gorgeous bald head that's probably over here somewhere. All right, next. 9. Let me give you a hint on 6. You might want to turn it into degrees. Get some degrees in there, kids. Should be obvious. 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, cosine. So I'm telling you your cosine of your angle is between 0 and 90 degrees. So I don't know. Cosine, 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 cosine double angle. So we're going to go over to our double angle formula. And in this case, I've only given you cosine. So I want to find the I want to find the double angle formula that deals just with cosine. And that would be just this middle one, 2 cosine squared a minus 1. Now, of course, I'm going to rewrite it a slightly different way. So cosine of 2a, I'm going to use the 2 cosine squared a minus 1. But what this thing really means is it's the cosine of a squared. I'm going to get rid of that minus. It's the cosine of a squared. So I'll come in here and go, okay, you tell me what cosine is. Oh, it's 8 over 17. Okay. I could type that in my calculator, but that's 289. Let's see, I'm going to do this in my head. 289, that's 64 over 289. 128 over 289 minus 289 over 289, which of course everybody knows is 289. 128 minus 289 is 161. Negative 161 over 289. Let me just check my notes here. Oh yeah, I'm right. Moving on. The next problem I want to do after 9 is 11. I'm going right straight through these kids. 11. All right, so this one's a little bit different. That's why I want to cover this one. Oh, he's black anymore. It's boring. So I'm still going to use the double angle formula. And the only thing I was given was the fact that we have tangent and that it's in quadrant, let's see, 90, 180. That would be quadrant 2. So I go over to my formula sheet, and I want to pick the formula here that has just tangent in it. So I'm just going to use these three, and I want the formula in it that just has tangent. So just tell me which one has tangent. Go ahead. Oh, dang. I don't even have one that has tangent. Doggone it. Shoot. So I get to choose. I want to know why I did that. Get away from me. I'm going to go back. So I don't know which one I'm going to use yet. But I have to have either sine or cosine. So that means I say, okay, here we go. I know what I got to do. I got to come into the second quadrant, draw a triangle. 15 over 8, which makes this 17. Done this a bunch. And I might as well just use cosine. It's an easy formula. We'll do 2 cosine of a squared minus 1. Cosine of a in this case is 8 over 17 squared minus 1. Holy mackerels, is this the same answer? Oh my gosh, it is. Look at that, negative 161 over 289. But notice what I had to do. I didn't have cosine or sine, and in order to use this formula, the only formula I have has tangent. The only thing I have is to have sine or cosine in it. So I took tangent and the fact that it was in the second quadrant and figured things out. All right, kids, number 12. Let me rewrite that. No, 1 minus sine, no, I'm not going to rewrite it. Sine squared pi over 6. I don't know what pi over 6 is, so let me figure out what pi over 6 is by converting that to degrees, because maybe that'll make things a little bit easier. And I get 30 degrees. So really what this is 1 minus sine squared of 30 degrees. It kind of looks familiar. It looks like something I've been using. Let's go back to the formula sheet. Do I see anything maybe in this like red box over here that might say 1 minus sine squared of an angle? Oh, you do? You mean that looks exactly like what's on that other sheet? 1 minus sine squared of an angle, 1 minus, oh, so that's equal to cosine of 2a. So this is really equal to cosine of 2 times the angle. Well, the angle in this case is 30. Oh, well, that really just means we have cosine of 60 degrees, which is 1/2. What's next, kids? 13. Oh, I don't know why I'm doing this. Another half angle. You guys can do these. So I want to know the cosine of 1/2 x, which I know to be plus or minus. They only want the positive, so I can get rid of that minus. I can get rid of this altogether. 1 plus 7 over 32 all over 2. Let's see. 32 plus over 32 plus 7 is 39. Is that right? So I get square root of 39 over 64, which is equal to square root of 39 over 8. Is that right? That's right. There she is. What's next? 17, chillin', 17. (255 degrees. Well, I remember Mr. Krause saying, because that's me, and I said it, I know I said it a bunch of times, if it ends in a 5 and I'm trying to deal with this, I'm probably going to use 45 degrees plus some other angle. And let's go use cool purple. In this case, it would be 210, because 210 plus 45 is 255. And if I remember my formulas, it's cosine, cosine, switch this, minus, sine, sine. So cosine of 45, sine of 210, sine of 45, sine of 210. Now, before I do anything else after I write these parentheses, I'm going to deal with the fact that I know that one of the major issues is sines. It always comes up to bite you in the tail, and you don't want to have that. So I'm going to go through here. This is third quadrant, and cosine's negative in the third quadrant. This is third quadrant again, and cosine's negative in the, or sine is also negative in the third quadrant. Now, I have to think about 210 degrees. 210 degrees is 180 and a little bit more. So it's really right here, 210 degrees. Well, that is 30 degrees away from the x-axis. So that's my reference angle. This is what I really want to think about. This is my reference angle. Okay. So while I'm dealing with 210, I'm really thinking about 30, and the cosine of 30 is radical 3 over 2. In this case, it's negative because we're in the third quadrant. And sine, the sine of 30 degrees is 1/2, but we're in the third quadrant, so it's negative. Cosine's easy, it's just square root of 2 over 2. I mean, the 45s are easy to square root of 2 over 2. So this is negative radical 6 over 4. Now, this is a negative and a negative. Those make a positive radical 2 over 4, and there we go again, that same thing. We're negative radical 6 plus radical 2 all over 4. 20. So simplify, then find the exact, don't use your damn calculator, value of this. Well, I don't know what cosine of 20 is. I don't know what the cosine of 25 is, or a sine of 20. But that looks familiar. That looks like, it kind of looks like, well, actually it looks like this formula right here, doesn't it? Cosine of an angle, minus sine of an angle, sine of an angle. Let's see. Cosine minus sine. Oh, so this is really cosine of A plus B, where this is A and this is B. So this is really the cosine of 20 plus 25, which is really equal to the cosine of 45, which is square root of 2 over 2. 24. I don't know what the cosine of 75 degrees is. I could do a crazy thing and figure it out, but that's not what I really want to do. That looks familiar. This is really 2 cosine squared of some angle minus 1, and I think that's on my formula sheet. I come over to my formula sheet. I think I remember seeing that. 2 cosine squared of an angle plus minus 1. That's really cosine of 2a. So this thing is really just the cosine of 2a, where 75 degrees is the a. So this is really the cosine of 2 times 75, which is equal to the cosine of 150. Now, 150 is in the second quadrant, so I know my answer is negative. Got to think about how far away. Let's see. That's about 150. This is 180. And there are 30 degrees away. So I'm really talking about the cosine of 30, thinking about the sine. I already took care of that. And the cosine of 30 is the square root of 3. What the heck am I doing? Cosine of 30, I already have the negative. Square root of 3 over 2, so it's negative square root of 3 over 2. And I think I'm doing the last one. I said I'm going to do 25. Okay. I don't look like I'm on my formula sheet. Wait a second. There's really just a 1 there, isn't there? Oh, yeah, there's just a 1 there. So this is really the same as cosine of 1/2 theta. And I remember that formula. Cosine of 1/2 theta is, they only want the positive, so I don't have to bother putting plus or minus. The square root of 1 plus cosine A over, or in this case theta, over 2. So this is equal to square root of 1 plus 1/8 over 2, which is equal to the square root of 1, 8 eighths. 8 eighths plus 1/8 is 9 eighths. This is the square root of 9 over 16 if you just put this stuff in your calculator, which is, of course, 3/4. Square root of 9 is 3. Square root of 16 is 4. All right, kids, that's it. I've done most of them. You got to do the rest. Good luck. Good luck. Hit subscribe. Hit like. Go to some of the sites. Maybe we can say there's something cool that you'll like to see. All right. Peace out, brothers and sisters. Bye.